Now, in the laws of returns in this chapter, we have two laws: returns to a factor and returns to scale. By the way, returns to scale, that is the long run's law, long run production functions law, it's not there in the ISC syllabus. Law of returns to a factor, we can say laws of returns to a variable factor. This is very much there in the ISC syllabus, and it's very, very important. Variation of output in the short run, law of returns to a factor. Now, before going into the depth of this law, let me discuss briefly certain concepts. Actually, three concepts are very, very essential in the explanation of the law of returns to a variable factor. Some basic concepts: total product, average product, and marginal product. These three are the concepts. First, total product. Total product refers to the total quantity of output produced. Total product refers to the total quantity of output produced. That means total amount of output produced. Next is average product. Average product. Average product is the total product produced per unit of output, per unit of the variable factor employed. Average product or average physical product, same thing, of a variable factor refers to the output, total output produced per unit of the variable factor. We generally consider labor as the variable factor. Then we can express the formula of AP, average product, as AP subscript L. That means average product of labor. Average product of labor is equal to total product divided by L. That means number of laborers employed. In the numerator, total product. In the denominator, it is total number of laborers employed. This is average product. Now we come to marginal product. Marginal product refers to the change in total product resulting from the use of one additional unit of the variable factor. That means when one additional unit of the variable factor labor is employed, for that, what is the change in the total product produced? Suppose 10 laborers were used, total product produced 120. 120 units of output produced when 10 laborers were used. Now 11 laborers are used. That means one additional unit of labor is employed. One extra unit of labor is employed. Then for that, what is the change in the total product? See, it was 120, and when 11 laborers have been used, suppose the total product produced becomes 132. From 120, it becomes 132. Then what is the change in the total product produced when one additional unit of labor is employed? 132 minus 120, it is 12. 12 is the marginal product. And see, marginal product or marginal physical product, same. How do we express it? Marginal physical product or marginal product, MP, is equal to delta TP by delta L. Delta TP by delta L. That means change in the total product divided by change in the laborers employed. Change in the total product when one additional unit of labor is employed. This is marginal product. Now let me come to the law of variable proportions, or law of returns to a variable factor. Law of returns to a variable factor. This law. Now what is the law? Actually, law of returns to a variable factor is the same thing as law of variable proportions. First, the statement of the law. First is the statement of the law. What is the statement of the law? let me state the law. When more and more units of a variable factor are employed or are applied to a given quantity of a fixed factor, when more and more units of a variable factor, like labor, are applied or employed to the given quantity of the fixed factors, then total product increases at an increasing rate initially. Total product initially increases at an increasing rate, but eventually, that means ultimately, increases at a diminishing rate or decreasing rate. So what happens? Again, I repeat the statement, you may understand. I think you'll be able to understand this. When more and more units of a variable factor are employed, then the total product initially increases at an increasing rate and eventually increases at a diminishing rate. This is the statement of the law. Now we come to the assumptions of the law. There are certain assumptions of this law. Now what are the assumptions of this law? Number one, the state of technology is given and remains unchanged. The condition of technology is given and remains unchanged. Second assumption, it is assumed that some inputs are kept fixed and others are varied, though here the thing is only one factor is variable. Only one factor is very variable because it is short-runs law. So only one factor is variable, all other factors are fixed. Third assumption, the technology is such that it is possible to change the factor proportions. The factor proportions are changing. Let me consider capital and land, these are constant. And these we consider as fixed factor. And only labor is changing. Then the factor proportion, ratio of fixed factor to the variable factor, it goes on changing. That is why it is named as variable proportions. Fourth assumption, it is assumed that all the units of the variable factor are homogeneous. That means the variable factor like labor, when the labors are used, then all the units of labor are same, are homogeneous, and the labors of the variable factor are equally efficient. So I've stated the law, made the statement of the law, then the assumptions. Now, according to this law, what happens? That can be explained with the help of total product, average product, and marginal product. According to the law statement, according to what happens in the law, we can explain the law with the help of a table. With the help of a table, we can explain this. Now look at this table. Number of workers, that means the variable factor, number of laborers. That we are showing it's increasing. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total product, 100, 220, 360, 520, 650, 750, 840, 880, 880 again, and 830, and then 770. Average product, how do we get average product? Total product value, each value total product divided by the number of laborers used. Then we get average product. So we can get average product how? By dividing total product by the number of laborers employed. And this way, by calculation, we get the values of average product here. 100, 110, 120, 130, then again 130, 125, 120, 110, 97.7, 83 and 77. Now the marginal product. How to get the marginal product? When from 0 unit of labor it goes to 1 unit of labor, what is the change? That from 0 unit of total product to 100 units. So what is the change here? 100. From 1 unit of labor, from 0 to 1 it's 100. From 1 to 2, 1 labor to 2 labors. Then what happens? 100 to 220. What is the change? 220 minus 100? 120. In this way, by calculations, correct calculations, we can get the marginal product. So this table can illustrate the behavior of total product, average product, and marginal product. Number of workers, total product, average product, and marginal product. If this is followed, if this trend that is going on in case of total product, average product and marginal product is followed in case of the short runs law, that is law of returns to a variable factor, then this can be explained with the help of a diagram. This can be explained with the help of a diagram. So this diagram is very, very essential. Let me now focus to the diagram. Now see this diagram. In this diagram, in the upper panel, there are two panels in the graph. The upper panel, along the y-axis we measure total product, along the x-axis we measure units of variable factor. Along the y-axis of the lower panel graph, it's AP and MP, average product and marginal product. Along the x-axis we measure again units of variable factor. This units of variable factor means labor. Now, I said while stating the law that initially total product increases at an increasing rate. See, when total product increases at an increasing rate from zero at the origin, it increases at an increasing rate. A very steep rise is going on till a certain point, and till a certain point, at that point is called point of inflection. Point of inflection. After that point, the total product increases at a decreasing rate here. See, the slope, now it becomes gentle. Now the slope becomes gentle. Here the slope is steeper. Here the slope is steeper. And here it becomes gentle. Here the slope is gentle. Then, after reaching the maximum and remaining constant for a little while, after rising and reaching the maximum, it remains constant for a very little while, and then total product falls. And then total product falls. So this is the nature of the total product curve in the graph. According to the law of variable proportions, initially it increases at an increasing rate, then after the point of inflection, a certain point called point of inflection, actually at this point of inflection, the rate of increase of total product that changes from increasing rate to decreasing rate. It changes, and after this point of inflection where the rate of change occurs, then total product increases at a decreasing rate. After reaching the maximum, it falls. So this is the upper panel graph. In the lower panel graph, we have to show AP and MP. AP and MP. Now, for drawing the lower panel curves, that is AP and MP, from the upper panel graph, you have to draw two dotted lines. One from the highest point where the TP has reached the maximum, and is just about to fall. From that, a dotted line is drawn, a vertical dotted line, till the x-axis of the lower panel graph. Another dotted line from the point of inflection, it is dropped, and you stop at certain point above the x-axis. I would advise you not to draw till the x-axis. It would be easier for you. Now, as long as total product increases at an increasing rate, MP, marginal product, will be rising. See, marginal product is rising. And then at the point of inflection, this point, corresponding to this point, MP or marginal product reaches the maximum. Here, after rising, MP reaches the maximum. Marginal product reaches the maximum. Then, when total product increases at a decreasing rate, here, during this portion, in this portion, marginal product is falling. And when total product reaches the highest point, the maximum point, here we find the marginal product reaches a zero level. How do we understand zero level? Because MP curve cuts the x-axis. Whenever a curve touches or meets or cuts the x-axis, it is zero. So here MP curve meets the x-axis, so it's zero level here. And after the maximum point, when total product starts falling, in this portion, when it's falling, then MP becomes negative. How do you understand? because here the MP curve goes below the x-axis. When the curve goes below the x-axis, it is negative. So this is how we draw the MP curve following the total product curve. Now we come to the average product curve. One thing to be noted, the nature of AP curve or average product curve is also very much like MP curve, but there are differences. What sort of difference? Like, the similarity in the nature of the two curves is that both the curves, firstly, they will be rising, reaching the maximum, then it falls. But see, MP curve reaches zero level and becomes negative also. But AP curve never reaches a zero level or not, and no question of being negative. Now, what happens? The maximum point of AP, comes after the maximum point of MP. This is the maximum point of MP. This is the maximum point of AP. Then maximum point of AP comes after the maximum point of MP. Thus, see, initially AP rises and reaches the maximum, and AP reaches the maximum at such a point where AP and MP are cutting each other, intersecting each other. So AP's maximum point is that point where AP and MP are cutting each other. We all know that when in a graph two curves cut each other, intersect each other, they are equal. So here at this point where AP and MP are cutting each other or intersecting each other, at that point AP and MP are equal. And after that point AP falls. But AP never is negative. AP is never negative. So this is the nature of AP and MP curve. Okay, this is not enough. It's not yet completed, because we have to demarcate the three stages. See, right from the beginning till the level where AP and MP are cutting each other, that is the intersection point of AP and MP. This is stage 1. And stage 1 is called stage of increasing returns. From this point or level where AP and MP are equal, I've drawn this line. From this level till this dotted line, the second dotted line, that means the point where TP has reached the maximum and is just about to fall, MP is 0, till this line. This is stage 2. And after stage 2, when TP is falling, MP becomes negative, that stage after this line, that is stage 3. So these are the 3 stages. Stage 1 is called stage of increasing returns. Stage 2 is called stage of decreasing returns or stage of diminishing returns. Stage 3 is called stage of negative returns. Now, I think you have understood these 3 stages. What happens in the first stage? In stage 1, total product starts increasing at an increasing rate, and after the point of inflection starts increasing at a decreasing rate. During stage 1, marginal product MP rises corresponding to point of inflection, it reaches the maximum and then starts falling. And during the stage 1, AP average product continuously rises. It is continuously rising, and it reaches the maximum, the highest point at the level where stage 1 ends. There AP and MP are equal. AP and MP curves are intersecting each other. Now stage 2, stage of diminishing returns. In stage 2, the total product continues to increase at a decreasing rate, and at the end of stage 1, total product reaches the maximum and is just about to fall. And if we look down, we find during stage 2, MP, marginal product, continues to fall, and it reaches a 0 level at the end of the second stage. and AP, average product, will be falling throughout stage 2. It's stage 2. In stage 2, AP, average product, is continuously falling. Now stage 3, stage of negative returns. In this stage, total product is falling, and when total product is falling, MP, marginal product, becomes negative. It goes below the x-axis, and average product is still falling, but it never touches the x-axis because it is never zero. It is never zero and no question of being negative. So this is the diagrammatic representation of the law of variable proportions, or the law of returns to a variable factor. Out of these 3 stages, if a question is asked, which stage is the most preferred stage by the producer? Stage 2. The answer is stage 2. Stage 2 is the most preferred stage by the producer, because in this stage, total product reaches the maximum, and the second stage is such a stage where he will stop at the end of the second stage. The producer has to stop, because if he goes